Hello my dear students, I welcome you to NEET World. So this is the third session on questionnaire. I mean taking the previous year questions of EAPCET as well as in the upcoming session we will be solving for NEET and JEE also. So as of now we will be solving the 2025 AP EAPCET question papers, right? So this is the third session on this particular EAPCET question paper series. Okay, so now we have covered up to this many questions. In the last two sessions we have covered this 140th question and also 150th question. Okay, and the next 141 question, then next we will be looking into 142. Here what question saying is a liquid mixture of aniline and X forms a non-ideal solution with negative deviation from Raoult's law. So what is X here? So we know ideal solution, non-ideal solution, one of the very important topic from solutions chapter, that is chapter number 1 from your chemistry second year syllabus, right? So what is this ideal and non-ideal solution? See, whenever two components, let us say, in order to make a solution, we will be mixing something like solute and solvent, right? So let us consider we have a binary solution which is made up of two components like A and B. Okay, so now if this A, B are having same type of interactions between them, okay, so after mixing also, after formation of the solution also, the properties are similar because both of them are having similar like A and B are individually they are having similar properties. So after mixing also we can expect to show them as similar properties. But whenever both of them are having different properties, for example, see, when we mixing, let us say between AA particles and let us say BB particles, when we are taking them in the separately initially, okay, so before mixing it is, so AA is having different interactions and BB will be having different interactions. Now after mixing the solution contains like AB kind of interactions, right? So now due to the difference in their interaction, for example, now the AB interactions are more than this AA and BB individually. So now what happens? They will come closer. Therefore, this leads to form negative deviation from the ideal behavior, or they will not be. They will be showing negative deviation from the Raoult's law. Okay, hope it is clear what is this negative and positive deviation. Again, positive deviation means now the interaction between this AB after combination, after forming solution having lesser interaction, it means they will be expanding. Let us consider they are expanding, the interaction between them is lowered. Okay, so it means, for example, let us say these two solutions are taken 10 ml and this is also taken 10 ml. Now after mixing we will be expecting to show that 20 ml of solution should be there, right? So now when it is having negative deviation, so negative deviation means the interactions are more, so the volume you can expect it should be lesser than 20, that may be 19 or 19.5 or 19.99, something like this. So at least some little variation in the resultant volume will be seen. Okay, now when it comes to positive deviation, so the resultant volume should be 20 ml. So due to this positive deviation, the volume may be greater than this 20 ml. So you can consider like this. I just wanted to give you some kind of like easy explanation, that's why I am trying like this. So it will be greater than this 20, so it can be 20.5 or 20.1, something like you will be seeing little increment in the resultant volume. So this is what happens in the positive deviation. Now they are asking about solution which is showing negative deviation. It means with this aniline, what is the structure of aniline? See, aniline is having like this is a polar group here, NH2, right? So now to this, if we add, see, now we know this is also an acid. Okay, so to this if we add any base, okay, so whenever we are taking a mixture of acid base, so there will be interaction between acid and base now, so this results to form negative deviation. So look here, so we have phenol which is having acidic hydrogen here, right? So this is acidic hydrogen. So now between this hydrogen and this NH2 group, so we may expect to have hydrogen bonding, as well as I can also say this is a weak acidic and this is a weak base. So they have this acid base interactions also. So like this, so what they will be resulting? So it will be having a negative deviation from the ideal behavior. I hope it is clear. It will show negative behavior from the Raoult's law. Okay, hope it is clear. Now whereas ideal solutions obeys Raoult's law, this deviated solution, positive and negatively deviated solutions will show deviation from the Raoult's law. Hope it is clear. So phenol will be the correct answer. Hope it is clear now. Now what happens if I mix benzene and toluene? So benzene and toluene will be having similar interaction, similar type of interaction. Therefore, the resulting solution will be ideal solution. Hope it is clear what I am saying. Benzene plus toluene. See, benzene means simple benzene, you know. So this will be the benzene, and toluene means it will be methyl on this benzene ring. So both of them are having similar interactions. So resulting solution will be what? Ideal solution. Okay, hope it is clear. Now tell me, so I will be giving you one question here. So what is a resultant solution when we mix CCl4 plus CiCl4? So what is the resultant solution? Okay, whether it is ideal solution or non-ideal solution. If it is non-ideal, whether it will show positive deviation or negative deviation, I want in the comment box answer for this particular exemplar question. Okay, let's move further. Let's look into the next question. So here we have, consider the following cell. Yes, this is a cell given here. The cell reaction reached the equilibrium state. So what is the value of this concentration of Mg plus 2 to Zn plus 2. So how can we write this? Very easy again. See, we have, this is a cell reaction now. They are asking about this. So now we have an equation like this, delta G equals to delta G naught, right, plus RT ln Q. So the ln Q we have, this is the reaction, this is the Q means reaction quotient, this is the equation we have. So at equilibrium, what we know at equilibrium delta G is 0, okay. So from this we can get the Nernst equation also. What is Nernst equation? Here we have E cell equals to E naught cell plus E naught cell. So here I can say, so how we are getting, how we are getting that equation? So from this basic equation, delta G equals to delta G naught plus RT ln Q. This is what the first equation now. So from this, what is mean by delta G? This is NF E cell we have to take. And what about delta G naught? It is also minus NF E naught cell you have to take. Okay, whenever they mention equilibrium, so equilibrium, at equilibrium state delta G will be 0. It means this value will become what? 0 you have to consider. And here we have plus RT ln Q. So like this you can write. So ln Q means that is a reaction quotient, I tell you. Okay, at equilibrium this Q will becomes K, that is becomes equilibrium constant K. Okay, hope it is clear up to here. So now if it is 0, we are having with this, so send this side. So NF E naught cell equals to RT ln Q, I mean K here. So K means what? So reaction quotient. How can we write this equilibrium constant at equilibrium constant Kc here? See, this is nothing but, see, magnesium plus, here see, this is the first thing, so right here in the reactant side, and here this is a salt bridge representation, and here we have Zn plus 2. So this reaction giving rise to Mg plus 2, which is oxidizing, and the next ZnO, so which is undergoing reduction. So this is the thing you need to write. So whenever we are taking the pure substances like elements, their activity is 1. Therefore in the equilibrium constant you need to take product concentration by reactant concentration. So what is the product ion? Here we have magnesium, concentration of Mg plus 2, okay, by concentration of Zn plus 2. Like this you have to take. So where this denominator came from? This reactant side. Hope it is clear. Right here Kc value, this is the Kc now, right here. So Mg plus 2 concentration by Zn plus 2 concentration. So this is what you can take. So from this you will get E naught cell equals to RT by NF, see this I have sent here, which is equals to into 2.303 log concentration of this Mg plus 2 by Zn plus 2. This is what you need to write here. Okay, so now by simplifying this, see here they have mentioned 2.303 into RT by F. How much value they mentioned? This F value. So this is given in the question itself, that is 0.06. Okay, so I can say E naught cell equals to this value I am writing 0.06. Okay, what about N value? So how can we find this N value? Number of electrons changed here. See, Zn, magnesium losing 2 electrons and the 2 electrons are taken by zinc. So it means total number of electrons changed here is how many? 2. So n value is 2 here, right in the denominator. This n value is 2 here, write it here. Okay. So this value we have mentioned from here. Okay. Now what we are remaining with? Log concentration of magnesium plus 2 by concentration of zinc plus 2. This is what you need to take here. Okay, so this will be 0.03, write it here. So what we need here, if we know this E0 cell value, finally we can get this, the remaining log concentration of magnesium by concentration of zinc. So how can we get this E0 cell? See, during the reaction, magnesium undergoing oxidation, na? So it means you need to take E0 cell equals to, so what is the species undergoing oxidation? E0 of oxidation, what is that? Magnesium plus magnesium to magnesium plus 2 I am writing, okay, plus E0 of Zn, zinc undergoing reduction, Zn plus 2 to Zn. So this is undergoing reduction. So what is the oxidation potential of magnesium? See, in the question they have given reduction potential, but here I have written as oxidation potential, right? So it means take the opposite of this number. This is minus 2.36, now take it as plus 2.36, that's it. Okay, and plus what about zinc? It is undergoing reduction, now here they given reduction potential only, whatever the value they given, take it as it is. Hope it is clear. Now from this how much you will be getting? It is 0. Okay, here 13 minus 7, so how much it is? 6. Okay, so you can say 1.60. Hope it is clear how we are writing up to here. So now take E0 cell value is 1.6 and here we have 60 and here you have 0.03. Okay, so log concentration of this magnesium plus 2 by Zn plus 2 we have write it as it is. Okay, so this is how many times? So it will be, I can write, so 160 by 3. So 160 by 3 means 160 by 3 means it is around 53.3. So 53.3 in the first option we have now 53.33. So that is our answer. Hope it is clear. All the things from the very basic onwards I have discussed about this particular question. Okay, so from where we have started, by taking the Nernst equation to taking the Gibbs free energy equation, then deriving the Nernst equation, then applying this particular question. Hope it is clear now. Let us move further. See, for a reaction A to P is a first order reaction. Okay, so it's a first order reaction they have mentioned. The concentration of reactant A after 10 minutes of reaction is X mole per liter, and after 20 minutes of reaction the concentration of A is Y mole per liter. So what is the rate constant they are asking. So how can we do this? See, first order rate equation, how can we get this? K equals to 1 by T ln initial concentration by concentration at time T. This is what we have, right? So from this we can derive one more equation. So from this, see what I am writing, look here. So K1 T, send that side. So we will get K1T equals to ln A by me means what? Ln of A by me means ln A minus ln B. So ln of A0 minus ln of A time T. I can write like this, right? Okay. So what they are saying, so from this just substitute the whatever the values they given. So from that we will get ln at a time T. What is the concentration of A at a time T? See, they have mentioned after 10 minutes concentration of A is X. So I am writing this as, see, I can write this as ln of AT equals to ln A0 minus K1T. I can write like this now. So this I am writing, put the value at 10 minutes. So at 10 minutes means you can say K1 10. So this as ln A0, okay, which is equals to AT concentration is how much they mentioned, X, like this. Similarly second equation you will get ln Y equals to ln of A0 minus, see, for Y it is 20 minutes, write that 20 K1, like this. Okay, hope it is clear. These two equations. Now you need to solve these two equations. You need to solve these two equations so that you will get the answer. Okay, 15 minutes. So now From this, if you solve these two equations, you will get the answer. So how can we solve? So just look them. So ln of x minus, so minus ln of y you can say. So ln of x minus ln of y you can do. So what you will get? Ln of a naught minus k1 into 10. So here minus I am saying now. So this minus ln of a naught minus k1 20. So if you do this, so what we will get? See, this is ln of a naught, here minus ln a naught, that will be removed out. So what we will be having? So minus of minus plus. So 20 k1 we have minus 10 k1 we have this side, and here we have ln what they are asking in the question. So they are asking the concentration, the concentration of A was, what is the rate constant? Okay, so k value they required. So x by, so I can write this as x by y. So ln A by y means I can write like this. So this is how much we have? So 10 k1 we have. Hope it is clear up to here. So now they are saying answer in terms of log. So convert this ln into log. So it will be 2.303 x by y. X by y, we can write x by y like log of x by y. So I am writing 2.303 log of x by y we can write. Hope it is clear. Now send this into the denominator side. So we will get k1 equals to 2.303 by 10 log of x by y. Hope it is clear now. Yeah. So 2.30 by 10 means what? It is 0.2303 log x by y. So this is the option number 1 which is given 0.2303 log x by y. So that is our answer for this question, right? Let's move further. Hope it is clear. Yeah. So tell me, which are the following is most effective protective collide on the basis of gold number values? See, the gold number values, if we consider for these 4 options, so the least lower the gold number, more effective collide it is. Okay, so which is having lower gold number? It is for gelatin. So it is around 0.005, around 0.005, right? So gelatin is having lower gold number, so it will be most protective collide here. Okay. Then next, the charge on colloidal particle can be confirmed by electrophoresis effect. Okay, yes. So this is correct only now. So the based on the charge, they will be moving in the opposite direction. Okay, in the electrophoresis effect. Okay, and then experiment. And the next, Whitewood cream, this is correct only, this one. Whitewood cream is an example of aerosol. No. So aerosol here, it is not the aerosol. So it is a different one. So where do we have any option like that? Only first option is correct here. So first option, statement 1 is correct, but statement 2 is incorrect. Okay, so from where we got that question? From colloidal solutions, I mean colloids, surface chemistry, colloids you will be studying now, there you will be coming across the topic. Okay, again from metallurgy, here we have the ore concentrated from fourth flotation. Yes, tell me which ores are concentrated from fourth flotation? Only the sulfide ores. What? The sulfide ores. So from the given option, tell me which is sulfide ore here? We have only this sphalerite is only sulfide ore we have, right? So that will be only separated or concentrated by this fourth flotation. Okay, one of the important topic, that is fourth flotation from the metallurgy. Okay, so now tell me, match the following. So given molecules and their structure, their bond angles are given. So match them, try to match them. See, ammonia. So ammonia will be having what? Pyramidal geometry na. So what is the angle there? So if it is tetrahedral, we know it is 109. But due to presence of one lone pair electron, the bond angle getting reduced from 109 to 107 around. 107.8. Okay, so it means ammonia will be having 107.8. Okay, and the next here we have O3, S6 and PH3. See, we know PH3, this hydrates of 15th group except ammonia, the hydrates which have after like after this ammonia we have phosphine and arsine, ASH3, like this we have now. So all these hydrides, the bond angles are around 90 degrees, which are very close to 90, okay, 90, like 91, 90.3, like that we will be having, okay. So those compounds are generally considered to be Dragos compounds, and there is no hybridization in that particular compounds. Only ammonia will be having sp3 hybridization, and we are not explaining the hybridization in the case of these other hydrides of 15th and 16th group, okay. Only water and ammonia will be having the hybridization for the respective hydrides. The remaining were not showing the hybridization. Their bond angles are in and around 90 degrees, okay. Hope it is clear. Now phosphine will be having how much? Around 93 degrees, okay. That's what I am saying, in and around 90 degrees, it is close to 93, okay. Then next, so like this, so just check A2 and D3. So A2, D3 here we have, so you can go with this option. And B4, so B4, this is bent shape, we will be having around 117 for ozone, okay. And the next SF6 will be having 102, S6 will be having 102. Hope it is clear now. And let us move little more further forward in the question paper. Yes, this is again very important and conceptual question. Listen here, very useful one. See, given list 1, list 2 are given, we need to match number of unpaired electrons in the given compounds. See, first complex is what? MnCl6 3 times now. So first of all you need to find what is the oxidation state of magnesium. So tell me what is the oxidation state of magnesium. See, if you find maximum like oxidation state, let us say magnesium having X, manganese having X, plus how many chlorides are there? 6 chlorides. Each oxidation state of each chlorine is -1. So what is the overall charge present here? That is -3. From here we will get X equals to -3 plus 6. So X will be +6. So plus 3, plus 6 minus 3, that will be +3, right? So manganese is having +3 oxidation state. So what is the electronic configuration of manganese? So atomic number is 25. So it will be having 3d5, say 3d5, 4s2. So 4s2. From this, how many electron we need to remove? +3 means remove 3 electrons, 2 from here and 1 from here. So it will be having D4 configuration in Mn+3 oxidation state. Okay. So now D4 means take the orbitals of D4. It will be like this. D4 I am writing now. So 5 d orbitals are there. D4 means 1, 2, 3, 4, like this. Okay. Now what kind of ligands attached here? Halogens are weak field ligands. What I am saying, halogens are weak field ligands. So therefore there is no alteration in the electron pairing. So this will remains like this only. So ligands will use outer d orbitals. It means 4s, 4p and 4d orbitals are used for the hybridization and forms sp3d to hybridization and having how many unpaired electrons? 1, 2, 3, 4. So first A4, so A4 like this. Okay. Similarly, when we do it for like ferric, like this one, Fe+3 complex, here oxidation state of iron is in +3. Now tell me how many electrons are there? Iron oxidation state is +3 here and atomic number is 26. So out of 26, so remove 3 electrons. So it will be having 23 electrons. Those are like this. So it will be 3d5, 3d6, 4s2. From here you need to remove 6 electrons now, 3 electrons now, remove 2 electrons from s orbital and 1 electron from d. So it will become 3d5. So how many unpaired electrons are there? 5 unpaired electrons are there. And fluoride ion is a weak field ligand. Therefore 5 unpaired electrons remains like that only. So here 5. So B5. Like this we need to solve. Okay. Here again manganese in +3 oxidation state and this is D4 as we seen here, D4. But the ligand attached here is strong field ligand. What is that? Strong field ligand. Therefore it will pair up the electrons. See how many d orbitals are required? We require 2 d orbitals in order to use the inner orbital. Here we already have one empty d orbital. We require one more empty d orbital. Therefore this electron pairing takes place. So now how many unpaired electrons are there after pairing? So these are the 2 unpaired electrons like this. 1, 2, like this. See, these are the 2 d orbitals, 3 d orbitals we have. These are the 2 4, 5, 6 like this. You can use like 3 p orbitals, 1 s and this d. So d2 sp3 is a hybridization here. In the first case it is sp3d2, both are different. Okay, so from that, so how many unpaired electrons are there? 2. So it means you can go with C2. So like that you need to do it for this option D and tell me how many unpaired electrons are there and what is the hybridization, whether it is having sp3d2 hybridization or d2 sp3 hybridization. In the comment box I want answer for this particular option number D. Okay, so now based on this, just choose the option A4. See A4, there in only 2 options. Okay, the next B2, yeah, B is how much? B1 we have in only in 4th option. Okay, so you can go with option number 4 as answer for this particular question. Hope it is clear. Yes, so guys who are watching, so please, if you really like the content, the way we are solving, so just click on the like button first and you can continue the session, and you can also share with your friends. Okay, I am watching into the chat box, so if you have any queries you can write in the chat box. I am looking into it. Yes. Then next, let us move further. Here we have, which one of the following oxidizes manganese salt to permanganate? See, manganese salt means here it should be Mn+2, right? So Mn+2 salts. So Mn+2 salts, to oxidize this Mn+2 we require a strong oxidizing agent like so K2S2O8, okay, which is a very strong oxidizing agent. Okay, then next, here we have PAN, polyacrylonitrile is used as a substitute for wool in making commercial fibers as acrylion. The structure of it is, so what is the structure of it? So it is nothing but, see, you know na ethane na, so to this ethane, so you know this ethane, right? So this, write this ethene, okay, ethene you are writing. So for this, here if we write 2 hydrogens we will say ethene, but remove that hydrogen and replace it with cyanide. So this is the monomer unit of this PAN, polyacrylonitrile. Okay, and what is its polymer? So its polymer will be, see, by forming these bonds, so what happens? So this will be making the bonds and this side will get a chain, and with this carbon will get a long chain, and cyanide lies here. So we will be having a polymer like this. So option 3 is the answer for this question. Okay, cyanide group should be there. Here they given isocyanide, so it is wrong. Here they given alcohol, this is also wrong. Only this nitrile group or cyanide group we can say that should be there. Okay, that is there only in the option 3, so it is correct one. Okay, next, which one of the following is a non-reducing sugar? See, glucose. See, whenever they are asking question about reducing and non-reducing sugar, so there should be free aldehyde group. I mean, see, it should be having acetal, I mean hemiacetal or hemiketal form, then only they can be like act as reducing sugars. Okay, if it is not having this hemiacetal or hemiketal form, or if it is having acetal or ketal form, they are non-reducing sugars. So what is this like hemiacetal form means? See, OH, H like R. See, we know aldehyde na. So what is the aldehyde structure will be having functional group like this na. So it should be converts into this form. So it should be converts into this form. So like this, there should be one group like this. Okay, I can say this, this is what? Aldehyde. So aldehyde giving acetal, this is what? Hemiacetal. What is this? Hemiacetal. Okay, it can be OH or OR also. Okay, OR also. Like this, it will be the hemiacetal form. So this kind of group should be there. So that is there in this glucose and fructose, maltose. In sucrose, you will not be having this kind of linkage. So how can we get this this hemiacetal or hemiketal form? So you need to check into the, look into the cyclic structures. How the cyclic structures of this glucose, fructose, maltose, sucrose will be having. Okay, so from that you will get the answer for this kind of questions. Okay, so one day we will be definitely having a special session on biomolecules, especially on these carbohydrates, where I will be explaining everything detailedly up to advanced level. So you can stay for that, stay hold for some few days. We will be covering that session about this reducing, non-reducing sugar, how can we identify, all those things I will be explaining them. Okay. Then next, the disease caused by the deficiency of pyridoxine. So pyridoxine what? So that is something like convulsions, we can say na? Yes. So we have here convulsions. So this is again direct static question, like if you know the concept you can directly answer this. I mean, you know, if you have read in the book, so you can directly answer this. Then next, identify the pair which is not correctly matched. Okay, this is again from chemistry in everyday life. So tell me, so aspirin prevents not correctly matched. Aspirin prevents platelet coagulation. Okay, next histamine dilates smooth muscle in bronchi. Okay, histamine stimulates the secretion of, yes, see here they are given two statements about this histamine. Look here, histamine what it will do? So it will do stimulates the secretion of HCl in the stomach, so that is correct only. But here you can see histamine dilates a smooth muscle in bronchi, so this is the one you need to choose which is not correctly matched. So this is not correctly matched, you can go with option number 2. Okay, here we have a question from organic. Tell me, what are X and Y? What are X and Y respectively in the following reaction? So tell me, so here we have OH group now, here we have Br2 and red phosphorus. What happens? That will convert this into, OH, remove OH group and replace with Br. So you will get an option like this, answer like this. Okay, here, and this one is what? We have carboxylic acid and we are treating with bromine and red phosphorus. This is HVZ reaction. So what happens in HVZ reaction? So at alpha position, see, to this carbonyl group of this carboxylic acid, this is the alpha position, this is beta position. So at alpha position, bromine substitution takes place. So you will get a product like this. So these are the two products. One is 1-bromopropane, another one is alpha bromo carboxylic acid. Br, this is Br, like this. Okay, so look into the options. Where do we have? Yes, see here we have option like that. So that is our correct answer. Okay, then next, look into it. See, we have amine group, NH2 group here and NaNO2. What happens? So this NH2 group convert into diazotization, I mean N2 molecule. So whenever we treat with these, so this NH2 group will be converts into N2 plus, benzene will remains like this only. Okay, so this will converts into this form. Okay, and upon treating this with see whatever the methyl group, that will remains undisturbed like that. So this Br2 we are treating now, so just remove this N2 from here and replace it with Br. Okay, so just remove NH2 and replace it with Br here. Okay, similarly here also. So let us see options. See, our Y should be something like this. Yes, here we have, and what about our X here? So X will be same happens here, this will convert into N2 plus, and after that, so here we have this alcohol now, so from that we will get hydrogen and remove this and replace with one hydrogen. So here we have that X and this is our Y. So option 2 is correct for this question. Yeah. So this is hydroboration. So given alkane, treat it with this B2H6. So what happens? At one position alcohol and at one position hydrogen should be OH and H is added, then further oxidized to form the respective carbonyl compound and treat it with NH2OH, so that you will get a product of hydroxyl amine. Okay, so that happens in this reaction. And so this is our last question from this particular session. See, C3H6 means, can I write like this? Yes. Okay, so here we have 3 hydrogens, 1 hydrogen, 2 hydrogen, that's it. So we need to add B2H6 hydroboration. So and H2O2 means, so just remove this double bond and add OH here and H here. So PCC we are treating now, it means it will become an aldehyde like this, aldehyde we got, okay. So this aldehyde, just treat this with NH2OH. So this oxygen and these 2 hydrogens, remove and write the remaining part NHOH. This is what you will get. So this kind of option there only here, that is your answer. Hope it is also clear how we are solving this kind of questions. Okay. Next, remaining we have 3 questions here. So I will be giving them as the work. So this is what, this is based on Cannizzaro reaction. Just give a try. If not, I will explain in the next session. So you will be having the other session now, that will be the mathematics or physics you will be having after my session. So just follow the sessions, okay. You can give a try for this. I will do them in the upcoming session. So thank you for watching. If you have any queries, feel free to ask in the comment box. Thank you.